Gold. What does it mean to you?
Shiny?
Yes, it shines and makes a person feel as if he can hold the sun. People measure their worth by it, but all that glitters is not gold. When we gaze into the sky, 99.9% of what we see is actually the gases hydrogen and helium. Gold makes up only a tiny fraction of the remaining 0.1% of the visible universe. And yet, there is even gold inside of you. What defines gold? It's an element, a substance made of only one type of atom, each containing a specific number of protons. In the case of gold, that number is 79, which is known as its atomic number. All elements are organized into a periodic table by increasing atomic number. Theoretically, we could start with an atom of hydrogen, which has one proton, and add one proton at a time, building up to the heavier elements. And eventually, we'd make our own gold. Altering the elements is easier said than done. Creating atoms requires a lot of energy and heat.
I know where to get heat. Let's go!
It's kind of empty, isn't it? That's how most of the universe is too. But you're on the right track. Just look up. The same sun that's beating down on you now also provides the heat needed to make atoms. In fact, it's building elements as we speak. You see, the sun is a star, just like the ones in the night sky, and all stars are furnaces where the elements that make up you, me, and everything else are created. And where do stars come from? Well, every star was born from a nebula. A nebula is like the kitchen pantry of the universe. It contains protons and electrons, the basic ingredients for any element. So, if we want to cook up some gold, this is the place to start. The nebula is kept together by the force of gravity, which pulls the particles in towards the center. Once gravity brings them close, a proton and electron are drawn to each other by electromagnetism.
Huh?
That means opposite charges attract. This bond creates an atom of hydrogen, atomic number 1 on the periodic table. Only 78 elements away. As gravity pulls more particles in towards the nebula, the increased density of the hydrogen atoms causes them to collide with one another. It's like gold nuggets in a pan. Whether it's gold nuggets or atoms, collisions produce heat and raise the temperature. This is like preheating the oven in our kitchen. The nebula is known as a protostar until the right temperature is reached, then it officially becomes a star. This is where things really get cooking. The ingredients are combined to make elements.
Okay, I'll have 1 plate of gold, please.
Sorry, that will have to wait. At this point, the star only has one ingredient to work with, hydrogen atoms. Get enough of these, stir well, cook at the proper temperature, and...
Is something burning?
Yes, in fact, it's the hydrogen burning. In hydrogen burning, 2 atoms of hydrogen fuse to produce an atom of helium, atomic number 2. We're making progress. The reaction is called burning because it's like a nuclear fire. It requires a lot of heat to ignite, but it pays for itself by producing heat as well. The star continues to burn through its supply of hydrogen, making helium and giving off heat energy. As its temperature rises, this energy creates outward pressure that balances against the inward force of gravity. As long as the star is making a profit of heat from hydrogen burning, it will be able to resist gravity and stay in business. Hydrogen burning can sustain the star for billions of years, but that's not what we're interested in.
Right.
So what happens when the hydrogen starts to run out? Well, as there's less fuel for the fire, then less heat is made. Gravity wins out and the star begins to shrink. It could collapse completely at this point, unless all that stored helium gets put to use. When the star contracts, the helium atoms collide more. The collisions heat the star up again until a new fire is ignited. Now, in addition to hydrogen burning, there's helium burning. 2 helium atoms can fuse to produce beryllium, or 3 helium atoms can make carbon. Helium burning costs more, so it doesn't yield quite as much heat as hydrogen burning, but it's still very profitable. Business is booming. The star is able to combat gravity again and grow bigger than before, but the helium can't last forever. The cycle is repeated, cooling down, contracting, colliding, heating up, and finally reigniting the burning of the next element. This is how the star is able to create new recipes for heavier atoms such as oxygen, neon, and magnesium. The star continues to expand from the heat of burning, forming layers. If it gets big and hot enough to begin silicon burning, then it has become a red supergiant star.
What's taking so long? I ordered a plate of gold.
Thank you for your patience. It's taken millions of years to get to this point, but luckily, everything after silicon burning takes less than 1 Earth day. During that time, the star builds up to sulfur, argon, calcium, and so on. But these recipes are more expensive, so each reaction produces a smaller profit of heat than the one before. The burning process stops with iron, because continuing beyond that point would use up more energy than it would make. No longer profitable, the star finally goes out of business and collapses.
What? I've never got my gold.
Trust me, it's not over. A star that massive goes out with a bang, literally. It explodes in a supernova, spitting out all of its contents with enormous force. The supernova provides enough energy not only to make all the elements after iron on the periodic table, but also to spread them across the universe.
Yippee! Gold! Let me at it!
Not so fast. Now, these atoms are recycled to form nebulae again due to gravity. Gravity pulls planets into orbit around a star, forming solar systems. In your solar system, Earth shares its star, the Sun, with 7 other planets. But only Earth has had the suitable conditions for the seeds of life to flourish. The first organisms appeared from nothing more than a jumble of elements, which began an unbroken chain of life that is billions of years strong, leading all the way to human beings.
That's me!
Who accomplished something that no creature did before. They invented science, and science has taken humanity a long way. Just think how much science helped you today.
But you didn't get me any gold.
You're right, and I'm sorry. We discovered something better, though. You see, humans insist on digging up all the gold from the Earth, while the true wealth of this planet lies in humankind itself. Every person born is more rare and precious than any substance in the universe. And yet, deep inside, people are no different from a nugget of gold or a speck of stardust. The universe made those things, and you, when it made the elements. Do you understand?
Yeah! Kinda.
This is ahead of your time, but I can tell you that a century from now, there really will be a plate of gold in space, floating away from the Earth. Well, not a plate, a phonograph record. But what it holds is the real treasure, not the gold exterior. It's a record of Earth's greatest hits, a collection of images and sounds that define this planet and its inhabitants. Scientists will launch it in 1977 on the Voyager spacecrafts. The Voyagers will help unlock mysteries of the solar system by probing deep into space. But the golden record is about giving human knowledge back to the universe. A long time from now, even after people are gone from the Earth, this record will remain like humanity's message in a bottle, floating through never-ending space. Just imagine another civilization discovering a Voyager someday. Rather than aliens, they will think of you humans as brothers and sisters, fellow children of the stars. Well, that's my ride. I have to go home.
Wait! Take this!
Thank you. I'm afraid you still have a lot to learn, but I know the good you can do when you put your mind to it. Remember, it's all in you. And welcome to the family.